Thank you for coming to the talk today. Today's topic is near and dear to me. We have been doing a long time project with the university, or Wake Forest University, in North Carolina, back in the States. They're a large medical research institution, and we got introduced to them through some other cloud partnerships to come and help them out. So this has been a really great, fun, but impactful project, and today we're going to take you through that, the life cycle of that, and how we've leveraged the Rancher portfolio and other SUSE tools to really establish a great foundation for applying infrastructure changes across medical research institutions across the country, leveraging this effort. But we'll talk through that. So the topic is called Saving Lives with Kubernetes. My co-speaker, Meredith Adams, MD. I don't have an MD, but she's way smarter than me. Was unable to make it. In the US, you have to apply for the right to travel specifically, and we were too concerned that this talk in person would be perceived as a conflict of interest, which would affect her ability to get medical research grants in the future. So we went ahead and decided, hey, we'll just record an intro from you, and then I'll give the rest of the talk. So here we are. So about the speakers, Meredith Adams, MD, MS, is with the Wake Forest University School of Medicine. She is an associate professor of anesthesiology, artificial intelligence, translational neuroscience, and public health services. She is one of those rare combinations of practicing medical doctor plus data enthusiast plus great grant writer, which at the end of the day makes all of this possible because you have to get paid and sponsored for the work that you want to perform in order to apply this. I'm Colin Griffin. I'm a founder and CEO of Crumware. We are a SUSE partner focused on helping customers perform implementation of infrastructure on both the application development side as well as the platform side. So we specialize in both areas.
Hello, my name is Dr. Meredith Adams. I'm a physician scientist that's an NIH-funded researcher in the United States, and I'm partnering with Colin Griffith and Crumware to solve some of the problems that are really relevant to the physician scientists in the United States. Colin's going to walk you through a lot of the details of how we did it and what we did to really get a functional data commons for pain and opioid use disorder. But what I really wanted to bring here was some context on why we did it. Normally in the United States, there's the technical world of research and then there's sort of the clinical research, and these are very separated spheres. And so having a solution that bridges both the technical and the clinical science and is understandable to the clinical researchers is a very rare thing. What we've been able to partner with and do is actually bring together a lot of those technical solutions and sort of platform advances to be able to really go at what the scientists need to be able to do discovery, to see what's happening with other projects, to connect their work to sort of a larger data ecosystem, and also meet those data standards that we need to protect patient information and have the privacy. While it sounds like a dramatic statement to be saving lives with Kubernetes, having the work that we do clinically with our research be able to be shared and discovered in new ways and that allows us to combine these data will hopefully provide a lot of these solutions to accelerate. And it does actually translate into saving lives, which is amazing.
So thank you, Meredith, if this is being recorded. I think she did a great job of presenting the problem here. So is anyone familiar with the pain and opioid crisis? It's a global thing. Yeah, it's affecting pretty much everybody knows somebody that's getting affected by this, even if they're communicating it or not. So there's a lot of initiative and effort in the United States to try to provide resources for this problem because it definitely is affecting society in a lot of ways. So Meredith's primary research and one of her current programs is called Empower, and it's a sponsored program from the NIH to apply and try to solve this problem. But for the NIH, the National Institute of Health in the United States, they also had a problem where they were funding medical research studies and the research wasn't being shared, it wasn't being democratized. So they would fund a big study, somebody would do their research, publish a paper, and then the data would go poof, would be gone. Nobody could use that. And there's been a concerted effort, and we'll talk about that here, to provide solutions and systems and requirements that allow the researchers to share their data with others. And that's a big focus of our implementation technically, is really enabling that to happen. So the pain and opioid crisis has caused devastating impact worldwide. Statistics alone, 4% of Americans have opioid use disorder. They're using pain pills and other things in ways that they shouldn't. In 2022, opioids were associated with over 81,000 deaths in the United States alone. The National Institute of Health is part of the United States Department of Human and Health Services, and there's a program called HEAL, which has begun the work of connecting a $2.5 billion portfolio of research in this space to bring all this together. NIH Empower is the first network studying this combination of conditions across 11 unique clinical trials. So this is the challenges, the tribulations, this is the process that we went through to help get them to production, really to ship this data commons platform and to set things up right so that we can print and stamp this repeatably many more times and allow other healthcare institutions to attack these issues and many other issues. So this talk will be a combination of business value and technical. So we're going to go through some of the platform implementation and what the parts and pieces look like there. But this highlights the importance of engaging the technical and business domain experts, the need for a flexible yet robust infrastructure, and the value of building on top of open source platforms. And it's really, for us, is the story of why we build on top of SUSE. So when we get started and we're building a platform or a new product or anything, we have to understand the challenges for the users. But our users aren't just the people clicking the buttons on the web app that we've deployed, right? It's also the people that are collaborating to make this product or this initiative functional. And our users include security engineers, data engineers, platform operators, data and SRE teams, all kinds of folks along the way. And we were put into a unique challenge at the start of this where we had a platform, but we didn't have tools for those users. So we're going to talk about that. But in general, we have clinical domain expertise, and then we have technical and informatics expertise as well beyond that. Aligning these goals will help us actualize the clinical research by giving, really truly by giving people the tools that they need to do their jobs in this space. So the reality of implementation. What happened with Wake Forest University is that when Meredith was doing her research, make sure I'm not skipping ahead, she went and found an open source project that claimed to be this one-size-fits-all solution. It really was, hey, run this Terraform script disguised as a bash script and deploy all of the infrastructure and everything you need. But the reality at the end of the day was it didn't work for them. It didn't fit their infrastructure. It required a different cloud provider. They didn't have any expertise or knowledge in the tools, and we're going to run through that. But in a high compliance industry, data sharing is limited and actively restricted despite the prevailing desire to share. So if people want to share data and they already don't have the expertise to do this correctly, how the heck are they going to make that happen, right? They won't be able to. This results really in siloed and fragmented research and invention and homegrown solutions. What that really means is that these individual research institutions continuously reinvent the wheel and try to build their own platforms, as opposed to building on top of the work of others. And it forces them to do things like learn Kubernetes when they really shouldn't have to. Also, the final thing is the risk of hype versus reality. I always want to add this. We're living in an age where we can talk about, how great everything would be, but the actual implementation and when the rubber meets the road is actually very difficult. And we're seeing that especially in, artificial intelligence and machine learning as well. We talk about how awesome and great this stuff is, but it's actually really difficult to implement, especially in production, and actualize these things. Let's see. So we need technical advancements to help facilitate solution development and speed to discovery. Speed to discovery meaning, trying to find and solve the opioid crisis, right? Things that we can do. So how do we shortcut that and get to the real meat? We need extensible and shareable tools and an open source mentality. We need to break down those silos and make sure we're able to share the technical components and other pieces with other institutions as well. As a part of this, we are committing and contributing to the upstream repositories and projects for a lot of these tools that we're using to try to make them more adoptable. We need reusable system patterns that offload management and improve research and development velocity. So we need blueprints. We need to standardize. We need to show other institutions how they can configure this on their own, customize, and deploy and get up and running as fast as possible. We also need to improve portability, right? We need to be able to move the infrastructure and move the data as well as do our disaster recovery and restore. So these are a lot of things that affect how we need to design and develop the platform solution underneath. And then we also need to facilitate secure interoperability. That's if institutions need to actively connect to each other and share research data without jumping through a lot of hoops, there is some additional security concern there, especially with PII, which is personally identifiable information. We need to make sure that the onus is on the researchers. They can just upload data into these systems. We need to protect the data coming in and the data going out and make sure it doesn't, we've got to protect the users, make sure it doesn't contain information that will compromise the mission of the project. All right, so now we're going to get into the technical meat since I gave you some of the background. This really is our journey going through development of the platform. So NIH HEAL wanted a new advancement in chronic pain and addiction research. They wanted to create a standard for how we share and democratize data. So they coined this term FAIR, which means the data needs to be findable, accessible, interoperable, and reusable. And they required that in order to participate in this, we needed a data commons that followed in these principles. So just some other examples of initiatives that are using the same concepts and have their own data commons. There are some heavy hitters here that are great to see. My favorite is Kids First, an institution out of the northern US that's focused on cancer research for children, which I think is really awesome. But Department of Veterans Affairs, the NIH themselves, the National Cancer Institute, BloodPAC, MidRAC, these are all major research initiatives in the billions of dollars, and they're using the same open source software product that we have put into an operational platform, right? So they had the same challenges. One thing that's not in the slides is the product that we're gonna talk about is a great product, and it's from the University of Chicago. And it really pioneered a lot of these things, and they needed to provide some of these scripts and things to deploy, help people deploy things. But their mean time to deployment, in some cases, is over a year to get this platform up and running. And by standardizing on SUSE, we've gotten that down to under a day, which is great. So it's really impactful from a learning standpoint and from a deployment standpoint as well. So not to spoil it. So some of the key tools. Meredith went through on her own as she was preparing for deploying a data commons. This is before she met us at all, and had to identify how the heck am I going to make this data commons happen. So she did what anybody did, and she went online and started researching and Googled data commons, right? And then she found this open source project called Gen 3 out of the University of Chicago that looked great. It purports it gives people Jupyter notebooks, it has deployment scripts, it has a microservices architecture, it's built on Kubernetes, it's all this great stuff, right? And so she thought, awesome, pick that, that's what I'm gonna go with. And she also contacted her local IT, and they said, hey, if you need servers, use Google Cloud Platform. We have a great deal with them. Just create a project and we'll just give you the project and you can do whatever you need in that project. Just don't spend too much money, please, right? And then there were already research data sources that we can use to pull from and seed the data commons and start to organize and build data dictionaries and do all the nice research. So the NIH HEAL themselves, if we think about these, the data commons are already open and you can download data and upload it to other institutions. You basically can just go to another data commons, download all this stuff and the schema and upload it into your own. And that serves as a great starting point. So NIH HEAL is what we're using for the seed for some of that. And then we also need to develop some custom tools. So in order to do proper research based on the studies that Meredith is doing, we need to be able to compare patient data as it changes over time, which makes a lot of sense. Currently, that open source platform doesn't have the capability out of the box to do that, but that's okay. They built in some UI extensibility. You can build your own apps for it. So we knew we were going to have to build some applications, or she did. So her journey was, hey, let me go read the documentation. I'm sure this is going to be easy. It was not easy. She hadn't heard of Terraform before, didn't know what that was. She hadn't heard of Docker before. She didn't know what a container meant, right? She didn't even know how to use the command line, right? She was used to Jupyter Notebooks, which you can do a lot of this stuff too, but the knowledge just doesn't translate, right? Especially when you get introduced to new tools. The other side was she started reading and realized this is all specifically built for AWS. You know, the Terraform itself, it was standing up AWS proprietary services. It was standing up Elasticsearch service, two major versions behind what was actually available in other cloud providers. There were she started going down this dark road that she was going to have to dig out of. So she likened it to IKEA furniture assembly without instructions, right? Or maybe even Legos at that point. And then there was the challenge of all things Kubernetes. When we met, they couldn't even pronounce Kubernetes, but I can't blame them. They just called it Kuber what and the Kuber thing. So tons of roadblocks when they're trying to get this thing rolling. When it was very promising, they thought they had an easy button, right? So they had to go back to the drawing board and rethink everything. They tried building something in-house instead, so they invested in an initiative there and wasted a bunch of time and money. And reached out. What they ended up doing is they reached back out to Google and they said, you know, we really want to use your services, but we just can't get this thing going. Can you help us with this project? Can you help get this Gen 3 data commons running? And again, it was built for AWS, so even if they had, spent a bunch of work on it, they wouldn't have been able to move it regardless, right? So we ended up getting in contact with them through Google, and I just had a chance conversation up near Wake Forest University with a member of the GCP team there, and talked about, one of the big focuses that we do is we come from the application development side. We are software developers first and foremost, and what our expertise really is providing developers with the right tools to ship their software. And so the thought was, if we're already operating from that perspective, maybe we can just go adopt that project and put it into the correct operational tools that we know how to use. We'd already built a practice with SUSE around how do we put in Rancher as an operational platform to provide developers and operators that don't have Kubernetes expertise with the tools they need to manage Kubernetes. So we just followed our standard platform patterns, and we're going to talk about the process that we went through to unfold that. Let's see. So before we jump into that stuff, I do want to acknowledge the challenge of upstream projects and the challenge it can be if you are the maintainer of that project and you do something like build your app on Kubernetes. They are an awesome crew. They're incredibly intelligent. They're incredibly talented. We love the University of Chicago. We have a KubeCon talk we did with them in Chicago last year. Please go look it up. It goes through a lot of these challenges as well. But they got unintentionally put into a situation where they built this thing, and suddenly everybody started asking them Kubernetes questions. They weren't getting asked questions about their own product anymore. It was just support my development on Kubernetes, how do I ship this, and they just got in this deadlock problem. So when we got, time check too, when we started working with them, we found they did have a Helm chart. They did have some Docker Compose. Everything was just kind of hodgepodge. They didn't know how to develop that to standard. So we were able to come in and help them. But this is really common with COTS applications and just across open source in general, is people don't understand how the operator user and their experience and how they can actually deploy and manage this software. And it needs more attention and focus, and we talk about developer experience, but operator experience is just as much developer experience, even though we're using a separate word. But I just wanted to acknowledge that they did an amazing job and got as far as they could, but it wasn't their duty really to drive this stuff home. All right, So when we got involved in the project, and this is the same process that happens across a lot of projects, we had to jump in and just see what was there. So our discovery process really is just, okay, read the manual, right? Go in, see what's there, try to set it up, play test it, run it. Let's check some configuration, let's explore, let's break some things, let's just try to see if we can get this thing up and running. Let's not care about standards. I just want to use the UI, I want to upload some data, I want to download some data and verify it and be done. Then we dissect the components, and then what we try to do is go back and backfill. If we see something is broken, but it's not a catastrophic break, we'll go back just like a bug report and go try to patch and fix those things, go work with the project maintainers, see what configuration we were missing. And every time we'd find one of those little holes, we'd patch it and we'd find another and patch it and find another. But as we iterate, right, we're working with the guys at the project, they can go adjust their Helm charts, their values, their templates, because they're not able to go play test this on their own, and they're certainly not going to do it in another environment when all they have is the infrastructure at their disposal. So over time, we were able to help them do just enough on their side to start to clean up and decouple some of the components so that we could be ready to deploy it. So discover and fill gaps and just test and test. This is their architectural diagram for their microservices. There are some components in here for security. They use a custom-built application called Fence, which is an authorization and authentication proxy. They use Nginx out in front. They proxy everything through an internal proxy service as well called Rev Proxy at the top, and that's how they do their authorization and authentication. They were using Cloud Storage Bucket, which really was just S3, right? Amazon S3. And this was deployed on EKS with Elasticsearch Service. So they had a lot of microservices and things that were there, but the challenge, while this looks like a great diagram, we could actually probably draw a big box around it, and all of this was tightly coupled together. We couldn't break out each individual service and deploy it on its own. We couldn't even break out Elasticsearch service, right? It was Elasticsearch wasn't even in the container or in Kubernetes. It was out in the managed service in AWS, so we can't move that, right? So lots of challenges there. This is a diagram that I use from the CNCF Platforms Working Group. This is a great tool to try to map the provider and consumer personas of a platform, as well as the different capabilities that are applied there. So we went and did an inventory of the tools and the parts and pieces and the third-party dependencies and things, and tried our best to put it into this diagram and group things together. So we needed to build a plan and determine, what should the platform actually look like. But I've got another talk later that talks a little bit more in depth about it. We have to understand what capabilities we're actually providing to these users and why we're doing that. Everyone gets really hyper-focused on the tools themselves and not the problems the tools are actually solving. So by using this diagram, we can break things into those capabilities like the infrastructure, the messaging. Now, one thing that I want to point out on the messaging, do I have a cool laser pointer on this thing? I don't think so. I'm not willing to risk it. This diagram from the CNCF doesn't typically, if you don't have an item in in one of these boxes, it's really difficult to communicate that it's up to the user to provide that capability. That's something in a lot of projects like this where they're providing a hybrid of the infrastructure and the apps. But just adding something as simple as saying bring your own to a diagram like this will help you share with the end user and say, hey, that thing, that infrastructure, you're going to have to bring that on your own. We're not providing that. Messaging as well. We transitioned it and used NATS, Synadius here, but before that it was just using SNS, Simple Notification Service, from AWS, but it didn't actually tell you and communicate that it was SNS. It just made it seem like it was built in, ready to rock and roll. So we went through and tried to map all of these different things. Another remark on the diagram, it's a little small in text. The bottom half of this is platform capabilities. So the providers, like the operators, will provide these capabilities via platform tools. And then platform interfaces is for the end users. How do they consume and leverage those capabilities? So that's portals, projects and templates, APIs and CLIs, user interfaces. In some cases, you'll see these both in some capabilities in both places. An example of that might be Elasticsearch and Kibana, right? You could argue Elasticsearch is a storage tool. All right, so there were some significant barriers. Out of the box, it used a Terraform, but it was run by a CLI tool that was a custom-baked CLI tool. Some of that should sound familiar. And the configuration complexity, it wasn't click and go. You had to understand IAM. You had to understand how to add roles. Even though there were the Terraform was there, it wasn't creating all the resources necessary. It just made some assumptions, and it was highly technical. A researcher doing this on their own, no way. There's no way they could have done that. There were uncommunicated dependencies on systems or providers. The AWS thing was kind of an unspoken thing. We had to figure that out on our own. And the CLI tool thing can be really annoying when we get involved in projects. Like, why do you have a custom CLI tool to just run a Helm install? Don't do that. It required advanced skill sets, Terraform, Kubernetes. It had no standard Helm at the time. It had significant day two setup. You also had, we're not even going to go into it, you had to figure out how to run data models and define your own schemas and data dictionaries and do the ETL, and none of that was documented. It's not just an easy button like it appears. So, inevitable ChatGPT plug. I like these little images that it created for me. But what we really have here is, like, we have a great application and a platform. It is a platform that's an all-in-one, which in some cases, if you know how to deploy it and configure it, can be really, really great, because then you're offloading the burden of having to design and build this thing yourself. But that also, the way that this was built, it's like this is a terrarium, right? You've got this plant, this thing, this ecosystem you're trying to take care of, but you can't actually touch it, but you can definitely see it. And so I like this diagram there. So they had this terrarium, this thing you can pick up and move around. So primary challenge, it was perceived as ready to go, but it wasn't. And this is just a rehash. Some of the business side, there is no maintenance and lifecycle considerations. How do we handle software updates? None of that. The cloud and infrastructure management side is totally up to the user, no guidance there. Bring your own governance and compliance. We're assuming that the IT organizations at these institutions bring that information and know how to do that stuff. Most don't. And then there's a lack of zero trust security. So while they have security and a proxy, it's up to you to protect the environment, the data, and everything else. And that's just a really difficult challenge. It's especially difficult if you don't know what the end customer's environment is going to be. So customer needs to roll their own on that regardless. So we needed to design a platform. So CNCF Platforms Working Group defines a platform as a collection of tools, capabilities, documentation that support developing, deploying, operating, or managing the delivery of products and services. Basically, it means the parts and pieces that are going to help you run your stuff or help other people get the tools and do their jobs, the things that they need. This is a big hype area as well. I'm sure everyone's hearing platform, platform, platform everywhere. I do encourage you to go to the platform working group meetings. Great discussions. It's a really diverse group of people across all industry. It's probably the best discussion group that I've been a part of at the CNCF. It's been really awesome. So when building a platform, this is internal to us. This is just kind of built on practice. We like to stick to some key tenets or characteristics. We want our platforms to be portable. I come from a critical infrastructure space. I don't want to be dependent on one cloud provider. I need things to be able to move around or be self-hostable. We need things to be resilient, right? We need to be able to have fast and active backup and restore. We need things to not just be fragile and break. We need them to be repeatable as well. So if I spent all this effort to implement one, hopefully that helps me implement many. I need it to be secure, compliant, obviously usable. We can have the most complicated system in the world, but it's worthless if it's not usable. We need it to be manageable, and we need it to be foundational. Everything that we do, we want to be able to build on top of. We want it to be extensible. We don't want it to be a closed ecosystem that needs to go be tended to by specialized people. We need something that we can apply even over in the financial industry or elsewhere and isn't just limited to this use case. So foundational is a key thing. And we should always try to build on top of our tools, right? So the platform approach lets us separate some concerns. We like the concept of a core platform, or some people could call that a minimum viable platform or thinnest viable platform. It's really what's the minimum set of tools that you need to get something just enough operational where you can start to layer some things in. Instead of calling it thinnest viable platform, I like core platform because in this case, we knew we needed some extra tools. We didn't need to make it as thin as possible. So I want a tool that comes with all of the foundational components that I need to be able to focus on the application and the architecture and the other components. So I think a core platform is something that's extensible. It can be progressively enhanced. Has anyone heard of progressive enhancement and that as a term? It's coined out of web application development. Everybody had a different browser, and in order to implement new features in browsers, the W3C needed to standardize and say, we need a way that somebody can opt into capabilities of a hardware device or a browser without breaking the experience of the user. So progressive enhancement is about feature detection. It's about opt-in. It's about, hey, if this phone has Bluetooth, then show this extra stuff. It's not, hey, you don't have Bluetooth, so you can't use my thing. So that's important to me. Also, positive supplier diversity in the tool chain. We need to have choice. And I don't say that to shill for SUSE, even though we're talking about choice a lot this week. It is incredibly important, and it gives the users a lot of power, but it also frees them up to go ahead and make the decision to implement a tool and have an escape hatch, right? So if we give them choice and freedom, we can let them choose our product and feel safe and secure and be successful and focus on what they need to. So it's really important to us, and that was a key reason why we started using Rancher 7 years ago. You get a reduced total cost of ownership as well. You're offloading some of the management and tools, and you also improve the time to production. So deploy the tool, deploy the thing that gives you the tools you need, and then start layering some apps into it. So we know we have an idea of what we're going to use, so let's jump into it. But we need to understand at the same time what the users actually need. So as we're designing the rest of the things, implementing security policies, nailing some things down, we have to understand what the capabilities of the end user, the provider end user, are going to be. So Wake Forest needs to be able to use this stuff. We're not just going to throw a tool in place again and put them in the same problem. So let's customize the experience, set things up, make sure that they can operationalize. What compliance frameworks are we going to follow? We went to the National Institute of Health and said, hey, what compliance frameworks do we need to follow? And they said, we don't know yet. We're watching this project from the University of Chicago to see what they do. And that was the same upstream project we couldn't get guidance on. So it's fun how it comes full circle there. Zero trust security was something that was talked about but not implemented yet, but we need to be able to do that. And there are other systems and tools that we might need to integrate with. So we need to get a clear picture of that. And all these other things everyone's used to going through. So to be ready for a platform, we need to loosen the coupling between the application and its dependent components. We need to be able to deploy those things and manage them separately. We need some freedom and flexibility in those tools. And basically, we just need to find a way to remove the glass around the terrarium. And I like this example because when you buy a plant from a store, you take it out of the flower pot and you put it in your own ground, right? So everything is kind of hooked together and has what it needs, and you can transplant it. So let's change it. Let's make it so that the platform is like the flower pot and the soil, the thing that's promoting the health of the plant, and let the application be a thing that could be pulled out and transplanted and portable, right? So what we need to build is start with the small flower pot. That's the core platform. Just enough tools to make this thing run and be successful. So what we did is we found the upstream Helm chart, and we experimented and standardized and corrected portions of the Helm chart. We flagged dependency issues. That was like Elasticsearch 6 verse 8. And hey, what are the challenges? Why can't you guys actually upgrade? Why can't we run on the modern version? Let's attack those. We implemented Argo to support multi-environment config and CI/CD that matches other GitOps patterns that we like to follow. We implemented Argo workflows for ETL. Reason why we did that is because we needed to be on our own release cadence for the upstream application and build our own images and be able to do some forking and customization. But we couldn't rely on their containers to be up to standard, so we just decided to build from source. And complement their containers when we needed to. To answer your thing from earlier, they did break out into separate containers for each of the services, but it was a monolith, and they were just calling different execution commands in the code base. But it's still better than nothing. We love Fleet. Honestly, this is a challenge that comes up in a lot of conversations is why Fleet, why Argo? You don't need to pick one. You can use both. One of the things that we like to use Fleet for is for the tools and the COTS applications specifically. I want to stay as close to the Helm as possible, and Fleet does really, really strong Helm management. I don't want to re-render into new manifests. So we use Fleet to manage the tools that are going to roll out into the clusters. And then for custom applications, or especially things where a developer needs additional intelligence into the app, we use Argo for that. And we find it's right tool, right time, right person, right? So Fleet is better for the operational user, and Argo can be better for the development user. So frankly, we're using both, and we've got another stack where we actually use Fleet to roll out Argo. But Fleet is lightweight enough. We don't need to kill it, and it's already going to be there to manage Rancher anyway. So let's reuse some of their stuff, and that actually kind of takes me into another thing here in a second. But yeah, Fleet for the Helm-based components, Argo for the application components. So what about the rest? We need to get this running in production, right? So we had the other diagram. Oh, it's supposed to, my transition's not here. It's supposed to swing in here. There it goes. Okay, so everyone's seen this, this chart from Rancher, or maybe not everybody, but Rancher suddenly starts to contain a lot of the things that we may have already had in that other, in the other platform. And maybe we want to reuse some of those components, but we didn't have a storage solution, so it brings us Longhorn, we can use that. It's got a Terraform operator, maybe we can reuse some of the Terraform stuff there. We can use Istio for service mesh, maybe we can stitch some, multiple instances together and start doing some of our federation. There's just a lot of things, including monitoring, observability, that just come out of the box. But it also gives us a better operator experience. So if those researchers need to deploy another custom app, or pull in a database, they can use that app catalog if they need to and deploy those things, right? So Rancher really is our core platform. That's what we use it for. So we make sure Rancher is in every implementation. We don't like using vanilla Kubernetes, right? We'll put Rancher in place and use that as the flower pot and grow around that. So this is the diagram from before, and you can almost layer this directly on top of it, right? It's just interesting how it lines up that way. And I think that's just thinking, industry thinking, being similar. But really cool to see it evolve that way. So from the bottom, we've got our ops, data teams, other personas, and from the top, we have our researchers, our users, who are going to get in there and use the apps that are running on the infrastructure. All right, so technical wins we get from this. Kubernetes non-experts now have an effective IT tool. They have something that they can grow with. The IT staff also gains governance and management capabilities. The app lifecycle is decoupled from the infrastructure as well. App dev now with Argo has a place to ship new apps and integrations. They could use Fleet too. And our data commons is now operational in GCP. So Rancher was able to abstract all the infrastructure management away, all of our downstream cluster management, all of those good things, and got us rolling. So now there's a clear path forward. We've got some business wins. We've gained compliance and governance capabilities. We have security practices that have now been implemented that they weren't capable of doing themselves before. Our disaster recovery and uptime is in the hours, big data sets, as opposed to no disaster recovery at all. The platform they had before didn't come with any guidance on that. We now also have secure interoperability via service mesh between other data commons, and speed. We massively gained on speed. Now we can just print and stamp new data commons one after the other and do some basic customization, as opposed to doing a custom implementation that takes months or years in any other given circumstance. So we've put a Kubernetes operational platform in place using Rancher, Longhorn, Fleet, the monitoring stack, the Rancher backup operator, right? We've just taken advantage of the entire stack and shortcut a lot of these things for us. We've operationalized now management and governance, and we also, as a bonus, we developed security as code profiles for NuVector and donated those into the upstream project. So if any of the other adopting data commons want to secure their application and use zero trust, all they have to do is helm deploy NuVector into the environment, and then next time they update their application, do a Boolean flag true to include the NuVector resources, and they're protected. I think that's a huge bonus win. And they also now have true infrastructure as code for the platform. Bonus business value, and I guess maybe I want to highlight it a little more, but bonus is nice. We're able now too, because we decoupled, we're able to reuse some of the components that came with the existing application and bring those into their own light. One of those areas was Elasticsearch was being used as a storage and search engine underneath the hood, but it wasn't being operationalized as an effective research tool. So we exposed Kibana. Right, we got Elasticsearch and the whole stack up to date, exposed Kibana, and now the researchers are actually using that as a preferred tool in many cases over the Jupyter notebooks that were in place. So I think that's really a big technical win, and all we had to do there was add some ingress, right? We wouldn't have been able to do that in the stack before. The portability is huge too. We've already gotten approached by other cloud providers to have offers to move this platform, and we could do that overnight if we wanted to. We could move somebody into GCP or out of GCP into AWS or into Azure. But on the other side too, there's a huge migration play that we can do now. If we use Harvester and some of the other tools, if we install this in their on-prem infrastructure before they're ready to be in the cloud, today a lot of these institutions think I need to be on AWS in order to use Kubernetes. So we could actually, using their existing infrastructure, operationalize this data commons platform and buy them time to move later if they end up wanting to move at all. And I think that's a huge business win for them. The templating, so being able to deploy more than one, there are millions of dollars behind each of these studies, and if the requirement to get your millions of dollars is to have a data commons, and if you need to do that in weeks as opposed to months, if you can get 10 research studies authorized by being able to print and stamp these, that's a pretty significant financial impact. But it also lets the researcher focus on the grant writing and not how the hell am I going to implement this. Let's see. And then the operational environment supports other applications and capabilities. So we can build and ship custom apps that work in complement to this and aren't dependent on everything being core and stuck and tightly coupled and working together. So technical recap, we used a minimum viable platform, infrastructure as code approach. We're using Terraform and then Rancher and Argo to roll out our other tools and apps and data. We've got Longhorn for snapshots. We're using the backup operator, GCP cloud storage. We now have GitHub repos for all of the configuration across the way. We've used NuVector for security, donated those policies into upstream for the greater good, and we've used a combination of Fleet and Argo as opposed to picking one over the other. All right. So at the end of the day, this is our platform diagram updated with the other tools and those areas there. One thing I didn't mention was the reuse of Grafana and Prometheus as an observability tool. They can use and monitor their ETL workloads and see what's going on there. We used Argo workflows for ETL as well and established patterns there, so some nice consolidation in the stack. And we also added open cost and cube cost, depending on the environment and who's licensing and all that stuff, so that people could we could monitor costs as well and try to pull that away from the GCP interface. So lots of good there. Also, we've enabled all kinds of additional personas. I didn't talk about it before, but I had them grayed out for a reason. Now we're able to bring in many different other user types from the organization to do the jobs they need to help keep this environment operationalized. And that includes the security teams, dev teams, governance folks that need to just observe and check and make sure things are running well. And then on the bottom half, the DevOps teams, even QA and SRE, now because we've implemented the Argo workflows and the ability to do builds and deployments based on PRs and all those things, we can test the environments and the UI changes just like we would any app dev stuff. And who would have thought you could do that with a COTS application, right? So instead of what we had before, which was just a little flower pot, now we have this extensive platform that's going to allow us to print and stamp many more unique applications and run them alongside each other. And the nice thing, because we've done this as infrastructure as code, and we're leveraging that core platform, we can print and stamp many more platforms as well and take that approach. So we're excited that other institutions are adopting these patterns, that they're able to take this open source approach, and hopefully, again, we've gotten their deployment time down from over an average of 8 months down to about 8 hours, which has been amazing to see. And you get to see the light bulbs from the people too, especially the ones that their research studies have been blocked because they haven't gotten their data commons up. Now the ability to just print and stamp that and meet their expectations has been really cool. So we're able to amplify life-saving research capabilities now that they have the tools they need. Cool. What's next? We're building some additional tools. We've got a harvester implementation that's ongoing for them as well, because we want to truly establish the on-prem and the hybrid cloud. We're providing this to other institutions as a golden path so that they can actually adopt this as well. And we're leveraging it as a way that the research institutions themselves can adopt operationalized Kubernetes by using the implementation of this as an excuse project, rather than be ready with all things Kubernetes before they deploy this. And then there's an additional effort to provide a better service mesh that's not dependent on having knowledge of the core infrastructure, so that all of these data commons can be interconnected and the data can truly be democratized. And we can only do that with the ecosystem-friendly nature of the SUSE products. Cool, so thank you guys.